Boeing 747 is one of the most recognizable airplanes ever built, earning the nickname, Queen of the Skies, after decades of carrying millions of passengers across the globe. Even though Boeing officially ended production of the 747 in recent years, the aircraft continues to serve airlines, cargo operators, governments, and VIP customers around the world. Now imagine what a 2026 version of this legendary jumbo jet could look like if it received a modern refresh while preserving everything aviation enthusiasts have loved for generations. The result would be an aircraft that blends timeless engineering with today's advanced technology, creating one of the most capable long-haul airplanes ever imagined. From its unmistakable hump-backed upper deck to its massive wingspan and four-engine configuration, the 2026 Boeing 747 would remain an icon in every sense of the word while incorporating the latest innovations in efficiency, comfort, and safety. The first thing anyone notices is the aircraft's commanding presence. Measuring more than 76 meters in length with a wingspan approaching 69 meters, the jumbo jet dominates every airport ramp it visits. Its elegant swept wings, towering vertical stabilizer, and signature upper deck instantly separate it from every other commercial aircraft in the sky. While modern twin-engine aircraft have become the standard for long-haul travel, the four powerful engines mounted beneath the wings still give the Boeing 747 an unmistakable personality. In this imagined 2026 version, those engines would feature the latest fuel-saving technologies, quieter operation, improved emissions performance, and advanced digital monitoring systems that continuously optimize performance throughout every stage of flight. These upgrades would reduce operating costs while preserving the impressive thrust that has always defined the aircraft. Performance has always been one of the Boeing 747's strongest qualities, and the 2026 concept continues that tradition. Capable of cruising at approximately Mach 0.855, or around 910 km per hour depending on altitude and atmospheric conditions, the aircraft would effortlessly connect major cities across continents without sacrificing passenger comfort. A maximum range exceeding 14,000 kilometers would allow non-stop flights between destinations such as New York and Hong Kong, London and Singapore, or Los Angeles and Sydney, depending on payload and airline configuration. Despite its enormous size, advanced fly-by-wire enhancements, sophisticated flight management systems, and refined aerodynamics would make the aircraft surprisingly smooth to operate while improving fuel efficiency compared to earlier generations. Inside the cockpit, the transformation would be even more impressive. Traditional analog instruments would give way to ultra-high-resolution panoramic digital displays capable of presenting flight information in highly customizable layouts. Artificial intelligence-assisted monitoring systems could continuously evaluate engine performance, weather patterns, aircraft health, and navigation routes while providing pilots with predictive recommendations before minor issues become significant concerns. Enhanced synthetic vision systems, augmented reality navigation displays, and advanced terrain awareness technology would improve situational awareness in challenging weather and low-visibility operations. Although two highly trained pilots would remain fully responsible for every flight, intelligent automation would reduce workload, allowing crews to focus more on strategic decision-making and passenger safety. Passenger comfort would also receive major improvements. Airlines could configure the aircraft for well over 400 passengers in a traditional three-class layout, while high-density versions could accommodate more than 600 travelers. Despite carrying so many people, the redesigned cabin would feel noticeably quieter thanks to improved insulation materials, redesigned engine nacelles, and advanced vibration dampening technologies. Larger panoramic windows would allow more natural light into the cabin, while customizable LED mood lighting would gradually adjust throughout the flight to reduce jet lag and improve passenger well-being during ultra-long-haul journeys. Improved cabin pressurization and humidity control would help travelers arrive feeling less fatigued after spending many hours in the air. The famous upper deck would continue to be one of the aircraft's most distinctive features. Originally designed as a premium lounge before evolving into an exclusive seating area, the upper deck could once again become one of the most luxurious spaces in commercial aviation. Airlines might install spacious business-class suites, private first-class apartments, or even executive meeting rooms for corporate charter operations. Wide aisles, elegant finishes, premium entertainment systems, wireless charging stations, and high-speed satellite internet would transform long-distance travel into an experience closer to a luxury hotel than a traditional airline cabin. Modern entertainment technology would play an important role throughout the aircraft. Every passenger could enjoy ultra-high-definition touchscreens with personalized streaming services, live television, destination information, multiplayer games, and seamless connectivity with personal devices. Fast onboard Wi-Fi would allow travelers to participate in video conferences, stream movies, browse the internet, or stay connected with family and friends almost anywhere in the world. Wireless Bluetooth audio pairing, USB-C charging ports, and universal power outlets at every seat would reflect the growing expectations of modern travelers who rely on their electronic devices throughout every journey. Cargo capability has always been another major strength of the Boeing 747 platform. Even in this 2026 concept, the aircraft would remain one of the world's most versatile heavy-lift airplanes. The spacious lower cargo holds combined with the aircraft's exceptional payload capacity would make it ideal for transporting freight alongside passengers or operating as a dedicated cargo aircraft. The distinctive nose loading door found on freighter versions would continue to provide unmatched flexibility for oversized cargo, allowing operators to transport industrial equipment, humanitarian supplies, aerospace components, and other oversized freight that cannot easily fit inside most modern aircraft. This versatility explains why the Boeing 747 remains highly valued by cargo airlines long after passenger production ended. Safety technology would represent another significant area of advancement. The aircraft could feature next-generation collision avoidance systems capable of processing real-time traffic data with even greater accuracy than previous generations. Advanced weather radar would identify turbulence, thunderstorms, wind shear, volcanic ash, and icing conditions far in advance, enabling smoother and safer flight paths. Hundreds of onboard sensors distributed throughout the aircraft would continuously monitor structural integrity, hydraulic systems, electrical networks, landing gear, and engine performance. Predictive maintenance software could automatically notify ground crews about components requiring inspection before the aircraft even lands, reducing delays while improving operational reliability. Environmental responsibility would also become a central design priority. Although four-engine aircraft naturally consume more fuel than comparable twin-engine jets, substantial improvements in engine efficiency, lightweight composite materials, aerodynamic refinements, and sustainable aviation fuel compatibility would significantly reduce emissions compared to earlier Boeing 747 models. Airlines operating the aircraft could increasingly rely on sustainable aviation fuels produced from renewable resources, helping lower the aircraft's overall carbon footprint while maintaining long-range capability. Future compatibility with emerging alternative propulsion technologies could also extend the aircraft's operational relevance for many years. One of the greatest strengths of the Boeing 747 has always been its versatility. Beyond commercial passenger service, variants have transported heads of state, served as airborne command centers, launched spacecraft, carried oversized cargo, fought wildfires, and supported scientific research missions around the globe. A modernized 2026 version could continue fulfilling many of these specialized roles thanks to its enormous internal volume, exceptional payload capacity, and proven reliability. Governments, military organizations, humanitarian agencies, and research institutions could all benefit from an updated platform capable of adapting to